With that being said, let me introduce you to MJ. MJ is a tech-agnostic software architect championing a holistic and pragmatic approach to system design. Guided by his philosophy, start small, dream big, he helps organizations build scalable solutions that evolve with changing needs. Let's give the last round of applause on the purple stage to Maciej.
Perfect. Hello, everyone. Today we will be talking about many difficult things, but we will start with the most difficult thing, which is my name and the surname. So, how to pronounce it? It's general, something like that. Maciej Jedrzejewski. But as it is very hard, usually for foreigners, it is just MJ. And you can call me always MJ. If you see me somewhere, call me MJ. Hey, I have a question, MJ, that's fine. And some things about me. I'm in IT for the last 13 years. I worked as a consultant, software architect mainly, also on leadership positions like tech lead. Currently, I'm working as a team lead. I'm a domain-driven design evangelist. You will see it today. Maybe not, maybe yes, we will see. And I live in a beautiful Switzerland. It's not photoshopped. So this is real green grass. So this is how Switzerland looks like. Thank you, thank you. And I'm also an open source contributor. You might know this repository, Evolutionary Architecture by Example. It's developed in .NET together with my friend Kamil Bączek. And I'm also an author of Master Software Architecture book. Maybe you have heard about it, maybe you have not. So the question to you, do you know this guy? Anyone? It's Charles Darwin. So British naturalist, biologist, who in 19th century came up with the theory of evolution. And in theory of evolution, one of the things that he described was that all species come from one ancestor. And you can think about it like 4 billion years ago, there was some mud, and this mud got bored, and it started creating lives. And this life started creating another lives, and so on and so on. And this is how we are here today at Craft Conference in Budapest, listening to the Evolutionary Architecture presentation, which, as the name suggests, has also to evolve. Yeah, software architecture. Software architecture is quite problematic topic because it can be either too naive or too complex. When we are talking about too naive software architecture, imagine that you join startup. And in this startup, you have to show some products with the names and description, and that's fine. It's like 2 weeks project, MVP. Release to the market, we will see what happens. And then someone comes and asks you for changing requirements. Now, let's add some colors, sizes, prices, statuses, and many, many more things. What do? We add another column and another column and another column and another to a table. And now our table grows to 150 properties describing products. So if our architecture will be too naive for too long, we will have a lot of problems. But if we start too complex, and now you can imagine, I don't know, maybe you know this apocalypse of RKK, Redis, Kafka, Kubernetes. Then microservices and all the things that we throw in to the product that we don't need in the beginning. Then we are ending up with too complex architecture. And this problem leads to the moment where we should react and we should change our initial feelings about our architecture, our initial thoughts. And then Unfortunately, we usually react too late, and it's too late to change something, too late to revert our initial thoughts. Another thing that causes these problems is project paradox. With project paradox, the problem is that usually we have a lot of decisions to make in the beginning of developing product, but the knowledge that we have about the business domain is minimal. The problem is that when we get that knowledge, we don't have that many technical decisions to make. And this is often causing problems of incorrect software architecture. And today I would like to come up to you with something which we call evolutionary architecture. And this evolutionary architecture concept contains 4 steps. First step is simplicity. So when we are starting developing our products, we should aim for as simple architecture as possible that is solving our problems. At some point, we will have problems with maintainability, probably. And that's because the complexity of our solution will grow, the size of the team will grow, maybe we will have multiple teams, and we need to think about maintainability. Next is the point of the growth. Not all products, not all applications will come to that point. I mean growth in the meaning of getting extreme traction. So maybe you started with 1,000 users, and it grew immediately, like within 3 months, to 500,000 or so. This is where you might need to think about different concepts that will support your growth. And then the complexity of the solution. At some point, the complexity will grow to the point that you will need to revisit most of your choices because it won't be supporting it anymore. And something that is very important, and I would like you to remember from that presentation, if I would have to select one thing, this would be the thing. Always choose an architecture based on your current needs and based on your current context, not a wishful thinking. What do I mean by wishful thinking? Yeah, maybe in 1 year we will have 1 million users, or we will store 3 petabytes of data, or so. Don't do that. But additionally, don't close the door. I mean, if you are today developing something very simple, don't close your door like, hey, now we did it this way, and we won't be able to use, for example, relational databases in half a year from now. Keep this technical door open as long as possible. And to support this presentation today, I would like to show you a real case of a healthcare domain. Imagine that we joined a startup that is building an application for private medical clinics. And usually, you will have some kind of requirements, spoken, written, and there should be a possibility of requesting and scheduling of an appointment. We should be also able to prepare a treatment plan, starting the treatment, complete the treatment, select drugs for the prescription, provide the drug prescription, manage patients' medical records, keep the history of the disease, prepare invoices, send invoices to the patient, and there will be many, many more. These are just example ones. So the biggest question is where to start? And the answer is with this book. This is my book as well, but it's for free. You don't need to pay anything for it. It's completely free. I am describing there how to analyze such business requirements and transform them into working software. It's not long, don't worry. 86 pages can be read during one evening. The thing is that when you do the analysis of your requirements, you will also at some point come to the grouping of these requirements. And this grouping will do will take all these features or requirements that you had initially, and it will put them into some kind of areas. And these areas should be highly cohesive. So this is what you should aim for. And when we talk about high cohesion, you can think about it like things that are closely related to each other, and they are focused on single purpose or business capability. So transforming it to software development, if you have invoicing, invoicing should not schedule appointments or should not provide drug prescriptions. Or if we take it to the real world, it's like you would hire the Formula One driver to prepare you a sandwich. We don't want it. We want Formula One driver to drive a car because he's extremely good in it, and maybe we want a chef who will prepare our sandwich, who is also very good in it. So this is this grouping, and this is something that we will base on. So, for example, our requesting and scheduling of an appointment can be coupled to the area which is called appointment scheduling. Then, preparation of a treatment plan by a doctor, starting the treatment by a patient, and completion of the treatment by a patient can be wrapped into the group or area which is called patient treatment. Then, selection of drugs and providing drug prescriptions. In drug prescription, medical records management would be responsible for managing records of the patient and keeping the history of their disease. And of course, we will have also invoicing as always. There will be maybe preparation of invoices and sending invoice to patient. And these ones, they will have some relations. This arrows doesn't really matter here, but they will always have a data flow. So they will be dependent on other areas that you have here. And when we are focusing on simplicity, I mean simplicity that is here. So when we start as software developers, we are usually creating very simple code. Then we go up. There is this Redis, Kafka, Kubernetes, microservices, anything that you want that are not working for the purpose, because this is important. They are good. They are great. I mean, Kafka, Kubernetes, Redis, microservices, they are great, but usually we are using them for our imaginary problems in our applications. So our main considerations in this step of simplicity is that we have around 3 to 5 medical clinics that will be using in the first 3 months our application. There are around 1,500 patients, 100 employees. There are different opening hours, but we are working in Europe. And SLA for availability, 99%. So we have around 4 days downtime for the entire year. Deployment strategy. For these main considerations that we had, what would you choose here? Single deployment unit or multiple deployment units? Single deployment unit could be a monolith, modular monolith, whatever runs within a single process. Multiple deployment units can be represented, for example, by microservices. And I guess here, single deployment unit. Yeah, because we are starting very small. And now the code structure, how it can look like. It can just replicate these areas that we grouped our use cases with. So we have appointment scheduling, drug prescription, invoicing, medical records management, and patient treatment. Important thing, it can be represented in the beginning just by folders within your code. Like when you are coming from the .NET world or Java world, you don't need projects. It can be one project with folders, that's it. Then within each folder, we will have our use cases. Like in appointment scheduling, I will have confirm appointment, I will have schedule appointment. And within each of those, we will have everything that is required for this concrete use case. So for example, we have a business rule, cannot be scheduled without valid insurance, and we have some endpoint. Also, we have a request. Of course, request can be a part of the endpoint. That's just a C# thing that we love to create classes. This is, yeah, my fault of the initial years in IT. And when we have these folders, we should somehow keep or make sure that we are not breaking our structure of our code. So where and what can help are architecture tests. And architecture tests, this is an example in C#, can, for example, guarantee us that the module that you can see above, which is called contracts module, can not have dependency on any of forbidden modules that I take. And you can do it also that, hey, each class that does not derive from that won't be derived from another class can be sealed. Or you can do whatever you really want. I don't know if it is supported in your language or in the IT environment that you're working in, but it's available, for example, for Java. It's also available for .NET. If it is not available, it's not that tricky to write it on your own. But what I don't like about it is that I wouldn't call it architecture tests, because software architecture is huge. It's a really huge topic. And I would prefer to call it solution structure tests, because then we are guaranteeing that within our code, within our solution, the structure is always correct. How can our database look like? For this case, we could have one single database, but what is important is that as we modularized our code into these folders, it would be great to also modularize our database from the beginning. And what you can do is that you can use the logical split. I mean, we have one single database, and now for each of our areas, now we can call it modules, we will have a separate schema. And with schema, we guarantee that they are not talking with each other. So if I want some information about, for example, patient treatment, and I want this information in drug prescription, I can ask patient treatment to give me this information, but I won't be able to access directly the schema within my database. Communication. Let's say we have communication between invoicing and drug prescription. What we want to do here in the beginning, when we are starting, when we are very simple, we can call the public API of the other module. Now, important thing, when we are talking about modular monolith, we are not calling it through HTTP. We are referencing it. But there is a problem, because now invoicing knows about drug prescription. So what you can do is that you can extract the contract of this public API to a separate project, and then reference this separate project, and but the implementation will be within drug prescription. So my invoicing will know nothing about drug prescription. Drug prescription will implement the interface, and my invoicing will use the interface that I am defining somewhere else. Another option, maybe this would be the case, like imagine patient treatment has to inform 5 different modules about something that happened within its boundary. So what it can do, it can send the event and inform all other modules, not by just referencing public APIs, because now I would need to call public API of drug prescription, public API of medical records management, public API of whatever else, appointment scheduling. Instead, I am just sending an event and I am forgetting about it. All the other modules, they listen to this event, and now they can read the data, they can do whatever they want, they can duplicate the data on their side, they can just use it, whatever really they want to do. And how to do that in a simple way is for such a small application, or like a karate club, or hairdressing company, which is very small, one-person company or so, you can use in-memory queue. You might say, what the hell, in-memory queue, but what if I lose this event? Well, you will need to fix it, but we are on a scale that probably it won't be a big deal to do that. If you are scared of it, you can use also your database. You don't need any external component like RabbitMQ. You can just use, for example, Postgres as a queue. So you are leveraging the component that you already have, the database, and you have all the things there inside that you can configure, like inbox, outbox patterns, and so on and so on. So summary of the first step, each of the module has schema. Then we have use cases. Use cases contain all the code that is related to the use case. So if I want to drop the entire use case, I am just dropping it. If I want to extract at some point appointment scheduling to a separate deployment unit, I just take the content of the folder appointment scheduling, extracting it to a separate deployment unit, of course adding some middleware. The important thing here is that we have also building blocks, because building blocks are always there. Building blocks, what can it be? It can be, for example, exception middleware or some API filtering or whatever else that you can use in many different places. By many different places, I mean all of these modules that we have. Then, the chapter number 2, focusing on maintainability. So we have our clinics. Now there are 20 instead of 3 to 5. We also have 10,000 patients. We see that patient treatment module is quite complicated, and we are keeping adding features as crazy. Drug prescription module is used way more often than others, and some modules are crude, and some are complicated. There are also 3 teams now. We started with 1. Now we have 3 teams. Looking at our architectural drivers, we see that we have a decrease in performance, increase in complexity, and the highest decrease of maintainability. So what do we do now with the deployment strategy? Do we go left or right? Right? Any other directions? You could do that. But in general, you need to remember that you still have very low user base. I mean, 10,000 users is not that many users, especially in such applications like supporting medical clinics. If it would be a transactional system where you have like tons of transactions per second, maybe yes, maybe no, whoever knows. But here in this case, I would stay with single deployment unit, but the code structure could be a little bit different. So now we could have a main project that will reference all these modules and will be responsible for registering them. But then each of our modules will get a separate project with a separate structure inside. So maybe on the above, you will have 4 layers, like API infrastructure, core application, whatever. Second one, maybe 1 project or 2 projects, like API and data access, and so on and so on. So important thing, do not copy the entire project structure between modules, because they are different modules. Some are, as mentioned before, crude, some are complicated, some are quite complex. So it makes no sense to replicate everywhere the same pattern that you just selected. The problem is that we already need to also extract these building blocks to a separate project, because now we will have different projects referencing the same code from these building blocks. Database structure, it can stay the same, but we might start observing some problems with traffic. And the first thing that we will probably observe is the problem of our web application. So we will need to scale. As you can see, we will have instance 1, instance 2. We are scaling everything. So we have 5 modules here, 5 modules there, because we are working with modular monolith. But now we need to complicate our architecture with load balancer. We need to add another component. Before we didn't have this component. Now we will have to have this load balancer to just load the traffic either to instance 1, instance 3, or whatever else. Then another thing which we might face is the traffic of the data read or data writes. Here is about a data read, so we see that we have some problems there. So what we do, we don't add cache. We just leverage what we have already, and this is something that I really recommend, leverage what you have. So you can use databases, you can use read replicas for these read operations, and then when you see that it's problematic, then figure out other problems. Additionally here, there might be not a problem of replicas, there might be a problem of indexes within your tables or with queries, how you wrote them. So first start with indexes, queries, then add read replicas, and only then think about adding another component like cache. So we have a communication here. We stay with this public API, but what we can consider right now is that, okay, we saw that we are losing several events or too many events, and what we want to do is we want to leverage the outbox and inbox pattern. So when we are sending something from one module, it's stored in the outbox as a message. Then the other module reads it and then processes the message that was stored inside the inbox table. And here you can imagine you could go with this in-memory queue if you still want to, why not? But you can also consider message broker already. Teams. We have 3 teams. So what would be the best way to divide these 3 teams is to divide them between business capabilities. I mean, if we have a cohesive area of medical records management and invoicing, we know that it is not touching anything else. Maybe the communication, yes, because invoicing was calling the drug prescription, so there might be a need for integration between these 2 teams. But in general, each team will be responsible for some cohesive parts, so we don't share it. Team A will not work on drug prescription. Team B won't work on invoicing. And as a summary of this second step, now we have one main, let's say, main project where we will have appointment scheduling, invoicing, and medical records management. It will still be a part of main. But as we saw that these 2 are quite problematic, we already separated them. We see that there might be a chance that we will need to extract them to a separate deployment unit in the future. We have 3 teams instead of 1, and we are now using this inbox and outbox pattern for asynchronous communication. Now we are having the problem of extreme growth. So our customer base is now 300 clinics. We have 100,000 patients, 10 times more than before. Patient treatment generates 40% of the traffic. It's also the most frequently updated. And we saw that we need another team to support the existing one working with this patient treatment. Well, architectural drivers. What we see here, decrease in performance, huge decrease in performance, also increase in complexity and decrease in maintainability. So now let's look at this performance issue. Deployment strategy. What do you think? Left or right? Right. Yeah, it makes sense, especially when you are having multiple teams, because when you have multiple teams working with, let's say, modular monolith, they are often stepping on each other's toes. That's the problem. And when you scale with more and more and more teams, it's always more and more complicated to handle the traffic from multiple teams. There might be also different reasons. You maybe want to have better security for one of the modules because you are storing the sensitive data there. Or you see whatever else, like module is frequently updated, much more than the other modules. Then you can take it and extract it to a separate deployment unit. So now our structure looks like that we have modular monolith, and we extracted patient treatment microservice. The problem which we have right now is also that we need to extract building blocks. And as we extract building blocks to a separate deployment unit, it's becoming here a package. So you can imagine it's a NuGet package, NPM package, whatever, that can be now used by modular monolith and patient treatment microservice. So you have another problem now, because you also need to care about versioning of that package. So keeping the, for example, major, minor patch versions, and keeping also teams updated. Maybe you will need another team to support the building of this building blocks package. So database structure, how it can look like. We might have now the issue that we will have multiple instances, and we will have, like on one instance, we will have 2 schemas for invoicing and medical records management. On instance 2, there will be 2 databases, one for appointment scheduling and drug prescription, and on instance 3, where we have patient treatment, there will be another database for this patient treatment. And now, if we have problem of scaling patient treatment, we are just scaling this one, and we don't care about this 2 above. Now, maybe this is a case where we want to add cache to optimize our reads. Maybe also we want to add cache to simplify the communication between our modular monolith and microservice. So this is this moment where you can consider it, and what I am trying to say is that wait with cache, because it might be problematic, you know? Like, you know probably this saying that, yeah, yesterday I had 1 problem and I added cache to solve it, now I have 2 problems. So this is exactly the case. Communication, still invoicing drug prescription can be done as before, but the problem is here that now we need to use some external component like a message broker, because we have a separate deployment unit. Of course, you can still leverage, if you used before, let's say database, and you used Postgres, you can still leverage it. So this is up to you what you want, but you can't use anymore here the in-memory queue. Unless, no, you don't. You don't. What we have right now at the end, we have our main solution where we have still appointment scheduling, invoicing, and medical records management, and we have drug prescription reports also in modular monolith. Here we have a patient treatment microservice that can scale independently to as many instances as you want for web application, and it can also scale to as many read replicas as you want. If you have problems with writes, you will also need to take a look at partitioning, take a look at sharding. So these are the problems that you will be facing with at this growth phase. And chapter 4, focusing on complexity. So imagine that there are new EU regulations, and as you know, there are always a lot of EU regulations. I came from Switzerland, but I lived before in Poland, so I know what I am saying. Due to new features, the drug prescription module became super complex. And we already see that it is hard to maintain it with the current code structure. Our team expressed concerns about it. Now we see that maintainability again decreased. So what we can do, of course, from the deployment strategy, we don't change anything here, but maybe we can look at the code structure. So imagine that we have the prescription. This is some kind of an object within our code. And now we have several different services that are modifying this prescription from the outside. So here there is some business logic, here, and there. This is our stupid entity that we have here. And we are adding and adding and adding more and more and more services. But our team thinks that something is really wrong. So what we can do is we can leverage event storming on the design level, and we can figure out what are the commands in our system and who triggers these commands. So we have a doctor, and this doctor can look for drugs for treatment, select drugs for patient, change selection, prepare prescription, modify, provide, and he can also cancel the prescription. And there are some business rules, policies that we have here, like no more than 10 drugs can be selected, or unique number is assigned, patient must have a valid insurance, and so on and so on. And here we have our object, and here we have events that are coming out of this object. So prescription, prepared, modified, provided, cancelled. And also here, drugs found, drugs selected. What we can figure out right now is that, maybe this can be handled in front end. So we don't need to take care about it in the back end, so the left side, drug selection and so on. We don't care about the state. This can be handled in the back end. And now, our prescription will get the command, cancel the prescription, that is called within this prescription, and then it will check by itself, is it within 1 hour from prescription? If it is, then we are changing the state and returning the information that prescription was canceled. So here we have a command, here we have our object, here we have our business rule, here we have the change, and here we have the business event that comes out of this piece of code. So what you can know today from the books, from tutorials and so on, you might have heard about some kind of an aggregate concept. Have you heard about it? So with aggregate, we are aggregating things which are related, and then we can perform some checks, operations, and so on. So our aggregate is a guardian of consistency. So you can treat it as guardian of consistency. So no business logic is happening around, so outside of it, that can change it directly. Everything is encapsulated within this prescription object. Database cache communication. As mentioned before, you can play around at that point in time. So you might have problems with database, then you are scaling it for reads, optimizing for reads, for writes. You might have problems still with reads, then you have this cache. Communication, maybe now you need or you want to have this indirect communication with using this message broker or so. So this is up to you. And what I want to say, I just showed you in the chapter number 4, how it can look like from code complexity perspective, but it might be everything else. It might be database-related complexity. It might be cache-related complexity. It might be also API-related complexity. Everything that you can think of can fall into this bag of complex things. And what I would like to tell you, I was supposed to tell you a joke about evolutionary architecture by now, but it is still evolving, so I can't. And what I want to say is that you should start as simple as possible. Always aim for as simple as possible solution. I know sometimes it's very hard, but you don't need to be this new kid on the block, like, hey, let's do this, and that. Let's throw everything in that project that we have then on our CV that we worked with everything. Really, be pragmatic. Evolve pragmatically also. Shift your technical decisions as much as you can to the future because of this project paradox that I showed you. Fit architecture to your current needs, not your wishful thinking. And assume that businesses change. And as businesses change, your architecture has also to change. Thank you very much.
MJ, thank you so much for this. Let me give you a little token of our appreciation while we load the questions. Be careful, there's a heavy thing inside. Do we have questions? Yep. Your diagram with the requirements look like a story map. If you're using story mapping in the process, it typically outlines not just the MVP, but also feature iterations. Should those future but already known requirements be considered during the architecture design?
It depends, as always. If this is a future requirement that, yes, in 1 year we will need to support 1 million users, the question is, how did you get that number? Because now you can be in a company that is having some other applications which are used also by around 1 million users. So there is a high chance that your application, new one, will also be used by 1 million users. But if you are a startup that doesn't know how the market will react, don't do that really. Like, cut these imaginary features, cut them out from your roadmap. So this is how I would always take it.
Okay. How to introduce the event sourcing in the middle of the way? How to migrate the existing data from the database to the event store?
For that, the best to answer would be Oskar Dudic. I don't know if you know him, but he's a great guy from that kind of topic. But in general, you can do that, of course, but you need to think if you really need it. I mean, if your application is this karate club or supporting some businesses in your local community and you don't need to know the full history of all the changes that you did, and you don't need to record all the business events, then it makes no sense. If you have to do that, this is another topic. So probably you will handle it in the chapter of handling the complexity. So chapter number 4. So this is where you will focus on it. But this is the topic like opening a Pandora box. So a lot can happen, and there are a lot of different circumstances, environments, so it's impossible to answer this question within 2 minutes.
I mean, the next question is kind of similar, right? What if we already have overcomplicated system?
What if we already have an overcomplicated system? I would say that you can go 2 ways. Either, so of course, you need to do some proper workshops. You can use event storming, you can use domain storytelling, whatever else, just to identify first your cohesive areas. And only then start thinking how you can deal with code to change it. So what you can do with code, you can use a decomposition, like you will be decomposing it one by one, feature by feature, to another module, or if you are based in microservices world, maybe it will be another microservice, so tearing apart part of the data. You can also use tactical forking. So you are forking the solution, then you are like getting rid of everything else that you are not focused on, and only this part of your code that you are focused on, or this area, will be refactored. So this is quite a hardcore strategy in my opinion, so I would always go for this decomposition, like one by one, taking out these features, but sometimes maybe it would be a better choice to just fork what you have, try to cut everything that you don't need, and leave only this small amount of code that you need for this cohesive area, and then integrate it within your application.
Okay, when starting, is it okay to use DDD? Is that considered simple?
You remember, I told that I am DDD evangelist, and I am DDD evangelist from the strategic level. I don't care about that much about tactical one. Of course, it is also important, but the most important is the domain-driven design on a strategic level, and this is exactly what we did here. I mean, finding out these highly cohesive areas at some point when you are modeling it using, for example, event storming or domain storytelling, out of these workshops, you will have things which are called subdomains, and then based on these subdomains, you will try to distill bounded contexts. By the way, there is a very good material from DDD crew on GitHub, so if you go to github.com DDD-crew, they have a lot of great materials how to do that things, how to, for example, distinct these bounded contexts. And then when you have this bounded context, you have to prepare a context map. So context map will define the relationships between your bounded contexts, also between your bounded contexts and external systems. So this is something that you will have. And in my opinion, all the applications that we are creating that are solving business problems are a perfect fit for a strategic domain-driven design. But then diving into tactical one, where you need to think about aggregates, value objects, entities, in my opinion, not. So you should not fall into that trap of, yeah, let's add the aggregate, let's do the value object, let's add an entity, and for example, skip the strategic part. If you skip the strategic part, then you are hacked up. If you don't skip the strategic part, it's way easier to solve the problems because you start already with these cohesive areas. And important thing here to remember is that whatever you have in the beginning, it's not set in stone. It will change because you will need to adapt to your business changes. So for example, if you set in the beginning, like some bounded context, let's say you have 10 bounded contexts, and your company is, let's say, leasing cars. But then your company buys a company that was leasing trucks. It's a completely different leasing. So now you might have some bounded contexts that fit perfectly for cars, but unfortunately they don't fit for trucks. If you put trucks into cars, then you will have a mess. So that's why you need to evolve with the requirements. You need to evolve with the businesses that change.
MJ, thank you so much.
Thank you. Thank you.